Okay, in this lesson we're going to continue on with solving single variable equations, but we're going to go beyond just the simple one or two steps that we've seen earlier. Okay, looking at this first set, we can see that we've got some equations here that look really different. We have two different variable terms. We have two different constants, and each of those variable terms are on the same side of the equation. That's going to help us out, but we're going to approach this a little differently in that we will have to collect like terms first step. So when I'm collecting 4m and 3m, I'll have 7m is equal to negative 21. Now I have just a single variable equation where I am going to need to use the multiplicative inverse rule. This is saying 7 times m. We're going to undo that multiplication by dividing. If I divide one side of my equation by 7, I'm going to have to divide the other side by 7. So this will eliminate, reduce, and I will have the left side of my equation simplified to just m, which is what I wanted, and then 7 goes into negative 21, negative 3 times. Okay, in this particular problem, my two variable terms are on the right side, but again, I can go ahead and collect them. Negative 6y and negative 2y would collect to give me negative 8y. Bring down my negative 32. This is saying negative 8 times y. That's multiplication. We undo that multiplication with division. So I'll have negative 8y, or negative 8. Divide each side by negative 8. This will eliminate. And then I'll have y is equal to negative 8 goes into negative 32. That would go in there 4 times. So still a two-step equation, but it started out differently because we had two variable terms on the same side of the equation. Okay, we come down here to our next set of problems. Things look a little different. We can see that we've got a variable term and a constant term on both sides of the equation. Okay, so what we will need to do is we need to collect all of our variable terms to one side and our constant terms to the other side using the additive inverse rule. It doesn't really matter which side you decide what to move where, so you could start really anywhere. There's 4 different places that I could start, but my second step will be very definite after I've made my start. So I could go ahead and say, well, I'm going to go ahead and start with subtracting 2y from the right side of the equation, which means I'll have to do the same on the left. So I'm going to start here and I'm going to deal with this 2y, and I want to collect it to the other side. So it means I'm going to subtract 2y from the right side of the equation, which means I have to subtract 2y from the left side as well. And again, I'm going to draw my computation line because I'm going to bring everything down eventually. So that will reduce from there, and I will have 7y minus 2y is going to give me 5y plus 5 is equal to 10. Now this looks like one of our traditional two-step equations where I'm trying to get that single variable term by itself. So I need to get rid of the constant here, which means I'm going to subtract 5 from each side. Draw my computation line. These will eliminate, and I have 5y is equal to 5. Now I need to get my y by itself, so I'm going to divide each side by 5. Undo this multiplication by division, so I'll divide this side by 5. That will go away, and then I have y is equal to 1. Okay, going over to my next problem, got something similar going on here in that I have two variable terms and two constant terms. I'm going to go ahead and, well, we could do a number of things. I usually like to keep my variable term positive, which means if I add 2m to each side, I will keep that variable term positive. So I'm going to start here with the last term. I'm going to add 2m to each side, getting my variable terms away from the right side and all over here to the left side. So I collect these, and I'll have 5m minus 5 is equal to 5. Again, it's just now my regular two-step equation. I'm going to try to get rid of that, get that variable by itself, but I have to start here with that constant first. So I'm going to add 5 to each side. This eliminates, so I have 5m is equal to 10. Now I need to divide each side by 5 because this is saying 5 times m. We undo that multiplication with division. So I'll divide by 5. So m will be equal to 2. Okay. Okay, on our next one, I'm going to go ahead and show you a shortcut. I can do 2 steps at once. Again, it doesn't matter where I start. I'm going to try to keep that this variable positive, so I'm going to go ahead and subtract 2w from here, which means I'm going to subtract 2w from here. Draw my computation line. This goes away. At this stage, I'm going to pause, and I'm going to change gears. Being I've reduced something from the right side of the equation, I need to go to the left side and reduce whatever's left here. The only thing I can deal with is my 3. I'm going to subtract 3 from each side. So now I have 3 eliminated there. So now I can collect everything. So I've got 6w minus 2w gives me 4w. And then 11 minus 3 is going to give me 8. Because I've done 2 steps at once, my problem becomes a little bit shorter. So now I've gone right to a single variable equation, or a single variable equation that just requires division. Because this is 4 times w, I'm going to undo that by dividing. And so w would be equal to 2. You could do that out long way if you wanted to, 2 separate steps if you wanted. I'm going to demonstrate that shortcut again. I'm going to go ahead and, let's say this time I'm going to deal with this negative 6a. I want to get my variable positive, so I'm going to add 6a to each side. That allows me to get rid of that variable term from the left side. So I've reduced something from the left side. The only thing I can do that I can still eliminate is to reduce this 3 from the right side. So I'm going to go ahead and subtract 3 from each side. That eliminated that. So now when I collect these two, I have 4a is equal to, this is actually going to be 11. And I can divide each side by 4. And I think you've heard me say before, fractions do happen. This one isn't going to reduce at all. So I can go ahead and identify that this is, a is equal to 11/4. Again, keep in mind that you needed to reduce something from both sides of the equation in order to make that one work. Okay, going on down here, things are looking a little bit different here in that we've got parentheses. And what this is saying is that I'm going to be multiplying everything inside this set of parentheses by 2. So I'm going to need to distribute this 2 to both terms. I need to multiply both terms by this 2. So 2 times 2y is going to give me 4y. 2 times 3 is going to give me 6 is equal to 14. A lot of times students just say, well, wait a minute, I've got parentheses here. I learned that, when I see parentheses, I have to do PEMDAS. I have to do, please excuse my dear Aunt Sally, however you learn that. I have to do what's inside of the parentheses first. And you're right, you would if you had all your numbers in there, but we've got a variable in there, and we can't really do anything with that variable. So now I have to, back out of that and go ahead and distribute through and see if I can work around it this way. So now I've distributed the 2 to each item. Now I need a single variable equation that I can go ahead and try to isolate that variable y. I'm going to subtract 6 from each side. This eliminates, so I have 4y is equal to 8. Again, I'm trying to get y by itself. This is 4 times y. I undo that by dividing each side by 4. So y would be equal to 2. Okay, and over here, again, I can distribute. So 5 times 3x is going to give me 15x. 5 times negative 2 is going to give me negative 10. Bring down my 35. I could go ahead and trying to isolate the variable x over here. So I'm going to add 10 to each side. So I'll have 15x is equal to 45. And then I'm trying to get x by itself, so I'm going to divide each side by 15. And that would give me x is equal to 3. Okay. Moving on to in this last problem here, we've got a lot going on. We've got the left side of our equation, we've got a parentheses, we've got a constant out here. On the right side of our equation, we've got parentheses again, and we've got a variable term going on out here. So we know that the first thing that we're going to have to do is we're going to have to carry out this multiplication with our parentheses. We need to deal with that distributing first. So I'm going to go ahead and just draw my distributing little arcs there. I'm going to bring the 30 straight down, but I have to multiply this x minus 1 by 7, both terms by 7. So that would give me 7 times x is 7x, 7 times negative 1 is negative 7. On the right side, I'm going to have 3 times 6 is 18, and then 3 times x is 3x. Again, I'll bring down the 2x. Okay, now looking at each of these equations, each side of the equation, we haven't had this step before, but I'm going to have to simplify. So this is kind of a new step, simplify each side. Okay, so on the left side, I've got two constant terms that I can go ahead and collect. And so I'm going to go ahead and do that. I'm going to say 7x, and when I collect 30 minus 7, when I collect those two, I end up with plus 23. So I simplified the left side. Now on the right side, I have two variable terms here that I can collect. So when I collect those, I'll have 18 plus 5x. Now I have a problem very similar to what I had earlier, in that I have a variable term and a constant term on each side of the equation. So I can go ahead and I'll go ahead and just do this the long way. So I'm going to subtract 5x from each side, one step at a time, but is what I mean when I say the long way. So that variable term eliminates from the right side. On the left side, I can go ahead and collect these. So I'll end up with 2x plus 23 is equal to 18. So now I'm going to go ahead and subtract 23 from each side. That eliminates. So now I have 2x is equal to, I'm going to end up with negative 5 here. Divide each side by 2, and x would be equal to negative 5 halves. Okay, so that kind of completes all of our lessons on single variable equations. Moving forward from this, you would probably be working on some word applications, word problems with this.